My name is Amanda Callahan. I'm a Senior Reservoir Engineer at California Resources Corporation, and today I'm going to be changing the color of pennies using ion plating. So the first thing to talk about for this is safety. There's a few chemicals that we're using that we don't want to breathe any of the fumes in. That's why I have the fan going right here. We also have safety glasses because you don't want anything to splash, and I'm going to put on some safety gloves as well, just to make sure nothing gets on my hands. So you also want to do this experiment in a well-ventilated area. So aside from the fan, you don't really want to do this experiment indoors. You want it outdoors where any of the fumes from the reaction can blow off really easily. You also don't want anyone to be downwind of it. So I have the fan pointing this direction and everyone else is on this side to make sure no one breathes anything in. So the first thing to start with is pennies. And pennies that are minted in 1982 or before are actually made of copper. Pennies minted in 1983 and after are 98% zinc and only 2% copper on the surface. So you need to make sure that you find pennies from 1982 or before, or this experiment won't work. So I have a collection of pennies that are from before 1982. I've already gone ahead and cleaned a couple of them. The best way to clean a penny is a combination of vinegar and salt water. So just things that you have at your house. You can also use this if you don't want to wait. So you put the pennies in the vinegar and saltwater solution overnight, or you can use like a metal cleaner and basically get it done immediately. So I went ahead and cleaned a couple of pennies. So these are shiny 1969 and 1973 pennies. So over here I have my hot plate and it's on a low heat. The mixture I have in here is a drain cleaner and zinc. And the drain cleaner that you use is going to basically modify what color your pennies come out as. So the one that I'm doing right now has sodium hydroxide as its main ingredient. So when you buy your drain cleaner for this experiment, look on the back at what the #1 ingredient is. A lot of them will have sodium hydroxide, some will have sodium hypochlorite. I've done both of those so we can see the results, but depending on what your first main ingredient is, that's probably going to determine what color your pennies come out. The solid zinc that I have in here you can buy online or from kind of a chemical or hobby supply store, but that's probably not something that you have around the house. So I'm basically going to take a spoon. This is a dedicated spoon for this experiment, so it's never going to be eaten or used again, and make sure that you don't use any of the supplies here. This is a dedicated pot for this experiment, dedicated fork. So I'm going to drop my clean pre-1982 pennies into the mixture of zinc, and this one is sodium hydroxide. And it's just kind of heating on a low temperature to kind of accelerate it. So if you leave this for a long time, it'll happen even at a low temperature, but the heat kind of activates the reaction. So we'll leave these in here for a couple of minutes.
And do you want a rolling boil or just warm and?
So you don't want it to boil, you just want to warm the solution up a little bit. If it starts boiling, turn it off, and don't let it come to a rolling boil or anything. So keep a close eye on it. So they've been in for about a minute and you can see that the pennies are already starting to turn a little bit silver. So this used to be just a plain copper penny and the zinc coating is already starting to adhere to the copper. So the way that this experiment works is I have just elemental copper, which is not as reactive, and I've dissolved it in my sodium hydroxide solution. And when that happens, all of the zinc ions start floating for free in the sodium hydroxide. When they see the copper, they have something to attach to. So now I have zinc adhering to the copper, making it look silver. If you use a penny that's actually made of zinc, nothing's going to happen because it's zinc and zinc. So that's why this will only work with actual copper pennies.
And are you changing the entire composition of the penny inside and out, or just on the outside they're adhering and changing color?
Just the outside. So this is actually only coating the outside of the penny. Everything on the inside is still copper. We're basically just forming a bond between the outer layer of the copper and adding a layer of zinc on top of it. So this is actually a really common industrial process because zinc is far less corrosive than most metals. So a lot of things that you'll find, like pennies, are made of zinc because it doesn't corrode as much, it doesn't rust, and you get a nice, even layer. So now I'm just going to flip the pennies over to make sure that everything's kind of covered. If one side is touching the bottom of your container, it may not get a lot of interaction, so you just want both sides to have some solution covering. So now that the silver's been in here for a few minutes, you can see that these are entirely coated in zinc now. So my pennies don't have any copper exposed, they just look like silver pennies. I'm gonna go ahead and put them in water for a few seconds to make sure that they're cool before I touch them and to clean them from any of the chemicals left on there. So after that, dry it off, and now I have a silver zinc coated penny rather than the normal pennies that you see today that are zinc coated in copper. So now that we have the silver penny cooled off from the water, I'm basically going to take my zinc coated penny, and this is safe to touch now, it's just zinc coated. There's no longer a reaction happening here. And I'm going to dry off the penny, and then on the same hot plate, I'm just going to add the penny to the hot plate to give it a little bit of heat. And what this reaction is going to do is actually bond the copper from the penny and the zinc that was on top to make an alloy. An alloy is a mixture of metals that are actually blended together. So this you add for about 30 seconds to heat on each side to make sure that everything gets a little bit of heat. So it's important to know that if you damage or deface US currency, that's actually illegal. So the pennies that you're making in this experiment are only for personal use. They can never be put back in circulation. So if you look at these pennies turned out black. And the reason for that is the main ingredient in the drain cleaner was sodium hypochlorite, and that instead of attaching the zinc made it into a zinc oxide, which comes out in a black patina like this. You can see that the penny now is almost completely gold on both sides. You can see that Lincoln is glowing now. So this penny is almost done on the heat, and you can see that now we have a bond between the zinc and the copper. So you can see, especially compared to my original pennies, this is what the plain copper one looked like. This is what it looks like after the heat. So this is my zinc plating, heating it to turn it into the brass alloy that you see. So this is a really fun experiment to do in Olympic years because you usually end up with a bronze, silver, and gold penny, just like the Olympic medalists. A fun fact about those is that the gold medals are not actually made out of gold. They're made out of silver and then plated in gold in a process pretty much exactly like this. They don't want a solid gold medal because it's too soft and it would basically bend and like morph into no longer a solid shape. But silver is a hard enough metal that they use the properties of that to build the metal and then just coat it in gold for the coloring. So similar to what we did, we don't really want to use copper pennies anymore. We use zinc and coat them in copper. I made copper pennies, coated them in zinc. You can kind of do mix and match with metals so that the object is made out of one thing, but it looks like something else if you want a different color. For more information about energy and the benefits of oil and natural gas, you can visit powerinCalifornia.com, or for more information about CRC and what we do, you can visit crc.com. Thank you.